Today we're going to talk about angle-side relationships in triangles. So first up are two theorems. The theorems are actually one theorem that's biconditional, and it says that if I have side lengths, one larger than another, then I know that the angles opposite are the largest and the smallest. So looking at side AB, that's the largest. So angle C is the largest angle, and BC is the smallest side, so angle A is the smallest. Now, the opposite that also works. So angle Z is my largest angle. So I know that XY is my largest side. Angle Y is my smallest angle, so I know that XZ is my smallest side. If you need a minute, pause the video and then move on once you're done writing this down. Next, we're going to look at these three triangles and try to apply that theorem. And the very first step is to know all the angle measurements. So I know the interior angles of a triangle have to sum to 180. I've supplied you with the first answer, that's 44. Pause the video, fill in the other angle measurements. Here we are. You should have gotten 60 and 82. If you did not, go back and check your work. Now, the smallest angle in number 1 is angle C. So I know this has to be my smallest side. I'm going to label these small, medium, large. Angle B is my largest angle. So the side opposite is my largest side. And 44, angle A, is my medium angle. So the side opposite is my medium side. So I'm going to list everything from small to largest. AB is less than BC is less than AC. So I want you to do the same for number 2 and number 3. So pause the video and then press play again to check your answers. Here you go. If you did not get this, go back, check your work, maybe talk to a neighbor, but you should have labeled everything small, medium, large, and then listed an inequality of the sides. I can do this also when I have the side lengths. So BC is my largest side, so the angle opposite that side is my largest angle. Notice these two sides are congruent. Remember the base angles theorem? I know that the angles opposite them must be congruent, but in any event, they are smaller than angle A. So I know that the measure of angle B is equal to the measure of angle C, and both of those are less than the measure of angle A. I want you to label these two triangles, small, medium, large, in terms of their angles, and then write an inequality to go with both. Then pause, press play again when you're ready to check your answers. And here we go. This is what it should look like. If you got something else, please check your work and maybe talk with a neighbor so that you can figure out what you did wrong. Now, the next theorem I'd like to talk about is the fact that if I know side lengths, there are only some side lengths that will allow us to create a triangle. So if you notice over here, I have a side that's 7, and I have two other sides, 4 and 4 each, and the sum of these two is bigger than 7. 4 plus 4 is 8. So I want you to imagine that this is school and this is home. The shortest way is between school and home is a straight line. But say if you stopped at the store, that would be a longer distance. So going around in this way has to be further than going straight there. So the sum of any two sides has to be greater than the third in order to form a triangle. But now if you look at this other case, I have two sides that are 3 and 3. And if I were to swing both of these around, you'll notice that they will never meet. So I could not possibly form a triangle. And even if they were, say, 3.5 and 3.5, they would finally meet once they were lying straight on the other segment, so you couldn't form a triangle with that either. So the two sides have to be larger than the third side. Here's the theorem stated in detail. Again, the sum of any two sides has to be greater than the third. So pause your video and copy this down. When you're ready, press play. Now, let's take a look and we'll apply the theorem. Let's look at these first three possible measurements. The sum of any two sides has to be greater than the third. So if I look at it, I know that 3 plus 5 has to be greater than 7. I also know that 3 plus 7 has to be greater than 5. And I also know that 5 plus 7 has to be greater than 3. So let's go check. 8 is greater than 7, 10 is greater than 5, and finally 12 is greater than 3. All three work. All three are important. These three side lengths can form a triangle. Now, in contrast, look at this case. 4 plus 6 has to be greater than 11. 10 is not greater than 11. Therefore, these three side lengths cannot form a triangle. One way, again, you can look, if you add the two smallest side lengths together, it has to be greater than the largest one in order to form a triangle. Next, if I give you two side lengths, I'd like to know the possible range of the third side length, range of values that is. So we're going to set up three inequalities, and my third side length is going to be x. I know that 4 plus 10 has to be greater than x. I know that 4 plus x has to be greater than 10. And I also know that 10 plus x has to be greater than 4. So adding these two together, I get 14. That has to be bigger than x. I'll subtract 4 from both sides. X has to be greater than 6. Subtract 10 from both sides. X has to be greater than negative 6. So let's look at this on a number line. Here is 14. Here is 6. Here is negative 6. All three of these statements have to be true. So I'm going to restate this with x on the left because I think it makes more sense. X has to be less than 14. X has to be greater than 6. And x has to be greater than negative 6. The only place that works is in between 6 and 14. All three statements need to be true. So therefore, x is between 14 and 6. This is always going to work if you add together the two sides. Oops, not x, 4 I meant. And subtract the two side lengths. So it will always work out that if I subtract the two side lengths, I get the smallest my other side can be. If I add the two side lengths, I get the largest it can be. And remember, it's a strict inequality, meaning x has to be bigger than 6. It can't be equal to 6. And x has to be smaller than 14. It cannot be equal to 14. Now, this one's a little bit different because I have expressions rather than side lengths. In this case, I have to write three inequalities. I will add the first one and the second one. That has to be greater than the third one. I will add the first now and the third. That has to be greater than the second. And I will add the second and the third. That has to be greater than the first. So I'm going to solve all three of these. All three have to be true in order for the triangle to work out. So let's combine like terms. 3x plus x is 4x. 8 plus 5 is 13. That has to be bigger than 4x minus 11. I'll subtract 4x from both sides, and I get 13 is greater than negative 11. And thankfully, that is always true. if I had gotten something that was false, then I could not have these expressions form a triangle. So now we'll combine like terms again. I get 5x, 8 minus 11 is minus 3. That has to be greater than 3x plus 5. Subtract 3x from both sides. I get 2x. And I will add 3 to both sides and get 8. Divide both sides by 2. X has to be greater than 4. Finally, the third inequality, 3x plus 4x is 7x. 5 minus 11 is minus 6. That has to be greater than x plus 8. So subtract x from both sides. That is 6x. Add 6 to both sides. That is 14. Divide both sides by 6. X has to be greater than 14 over 6 or 7 over 2. This has to be true. This has to be true. All three have to be true. So let's look at it on a number line. Let's see. 4 is here, and then 7 halves, that's 3 1/2. So 7 halves is there, and then I don't need to worry about this at all. So x has to be greater than 4, and x also has to be greater than 7 halves. So looking, these two inequalities are true out here. So I know that any value of x that is greater than 4 will allow me to create a triangle. So wasn't that fun? Now, the next thing I want you to do is your homework. And here it is. Tomorrow we will take a look at what you did and discuss any questions you have.